All right, so on the project for Calc 4 there, two projects you can choose from. So the first one, get yourself a box. So a cardboard box is fine. Um, just any kind of shoe box, whatever you like. I would put the origin at the corner, but you're welcome to actually put it anywhere you want to. Okay, Z is the height, and obviously X and Y along the bottoms. If you were to use a cylinder shaped box, I'd get like a hat box, I'd give you extra credit. If you want to make a triangular shaped box, you can do that. In other words, you have to obviously create your own box, put a piece of paper, like a piece of cardboard across the diagonal of a shoe box, for instance, something like that. Anyway, then you pick an equation of a surface. In 3D Calculator, they give you some examples. I will not accept the first one, the one that's the default one. I'm tired of looking at that one. However, that one does have everything you need. You need a max, a min, and a saddle point. You can have more than one of those, but you need at least one of those. Anyway, you're going to graph it on 3D Calculator. You're going to model the surface using clay or dirt or something else. People have used sand. I like sand personally, because it's cheapest. So we'll go and buy a bunch of clay. It's kind of an expensive way to do it. Whatever, but you're going to model the shape in there. You can also use 3D printing if that makes you happy. Lots of ways to do it. Okay, so you're gonna find a point on that, and you're gonna put a gradient vector at that point. So I can use a toothpick or something. Okay, and then you're gonna make another point, and you're gonna move to pick another point to move towards and find the vector between the two, and make that a unit vector on the model. Now find the directional derivative, that sort of thing. Compute the volume. That's a double integral. Okay, obviously. Then you can verify it by smoothing out your sand, for instance, and find the volume of the dirt or the sand. You could also, if you weighed it, like if you knew how much what the density of clay was, for instance, you could model how much thing you could find out how much it weighs, and you'd know how much clay you used, and whatever. Lots of different ways to do it. One time, a person printed something 3D print, and they put it in water, displaced water. Same thing. That's also your volume. Okay. Draw a contour map using obviously 3D Calculator, at least 10 different levels. Find the surface area of your model. Now there I put a video up on how to do surface area. We're not going to do it anything except for this particular project. Don't need homework for it, but it's on it's right by the link to it is right by the project. Okay, so what I want you to do is a voiceover or a video, whatever. So as you're doing it, put it up. You can either video it or you can just voice over the PowerPoint. If you got a video of stuff, making it, whatever you're doing, show all that, show all the work on paper, calculations and whatnot, and so I can follow along. Cool. Oh, and a tangent plane. So I picture a piece of cardboard with a toothpick in it or something. Whatever you do, you. That's the first option. The option two, you're going to get latitude, longitude, and elevation along with time. So you're driving on a road. I want it to be a curvy road, like say you're going around the on ramp to get on the highway. And so basically, you'd be driving along a space curve in essence. Okay, now I have a video that's posted. It's called Space Curve Project. So if you watch that video, it's right next to the project in Canvas. So on Canvas, there's a project link, and then there's right next to it is a Space Curve Project video there. Watch that. And it tells you how you just get an app for your phone. You drive along. It tells you where you were at such and such time. Okay. And then you're going to create, using that, you're going to create you're going to use the Excel. What I show you how in Excel to convert that latitude and longitude and elevation. I convert that to X, Y's, and Z's all in the computer. Okay. Now, if it was me, I would make my initial point the origin. Okay. But you can put the origin anywhere you want to. That's where I would put it. Okay. So in that video, which I'll show it to you right now. Maybe I will. Oh dear. Well, I'll just come back to it, I guess. No. So it's literally, right. So there is the surface area video. Here's the Space Curve Project video. Watch that. Okay, and that tells you how to use Excel to take your latitude and longitude to then basically be able to create your space curves. Okay, where x is a function of t, y is a function of t, and z is a function of t. Okay, then you're going to find the velocity at a time between a and b. Now, for me, I would personally try to make this curve when I'm driving. I try to drive it at the constant rate the whole time. So just maybe set it at 30 miles an hour, whatever it is. You can do this on your bike, on a one wheel. It doesn't make any difference. I don't care if you do it in your airplane, whatever floats your boat, bud. As you're going along, though, let's say I'm doing 30 around the overpass, to get over the on ramp. Cool. That means that I know I'll be doing 30. So when I'm doing the calculations with my space curve, it should come out to be 30 miles an hour. Now, I failed to mention this in the video. I do mention it in that video about the space curve. If you're watching that, I do everything in meters. So it's going to be meters per second. So you have to obviously convert to miles per hour. Find the tangent vector. That's the unit tangent vector, and graph that obviously on 3D Calc Plotter. Find the acceleration vector. Nice. Graph that as well. Find and graph the unit normal vector. Compute the centrifugal and tangential accelerations. What's the radius of the osculating circle? Is that consistent with real life? You can go on Google Maps and basically approximate the radius of the curve you just went around. That's easy to do. In the time you're on the path, say from 0 to 10 seconds, how far did you go along the road? Obviously, that's an arc length problem. And then again, present your PowerPoints along with all the write-ups that you did. And then, on that PowerPoint, I want you to do a voiceover, show me videos or whatever you did. That's the project. If you have any questions, you let me know.